Welcome everybody to the tour of the James Webb Space Telescope Eclipse Sun Shield showroom. So we're going to begin by just introducing ourselves and to say who we are. My name is Jake Lattis. I'm a sophomore at Tappan Zee High School, and I love to play soccer with my friends as well as participate in the debate team.
Hi, I'm Alex. I'm a senior at Tappan Zee High School. I like playing tennis and running cross country, and I hope to be studying engineering next year in college.
Hi, my name is Isaac Wex. I'm also a senior at Tappan Zee High School. I enjoy running at the cross country team and the track team, and I hope to study business at Binghamton University next fall.
And finally, I'm Matthew Connor. I served as one of the mentors for the group, and I'm in the middle of my sophomore year at Virginia Tech studying computer engineering.
So if you'll take a look before you, this is our knowledge space, which we are about to enter. As you can see above it, Team Aegis, that's our team emblem right there, which is designed by Isabel. As we enter the knowledge space and you look around and see a lot of images that show the devastating effects of climate change, which is an international crisis. And two of the biggest and most important aspects of climate change are global warming and ozone depletion, which are becoming worldwide problems. If you'll follow us around the corner, you'll see that climate change affects millions of humans and animals around the earth in all kinds of environments. And so we present to you in this large banner the Eclipse Sun Shield, which is our attempt to solve some of climate change's more serious issues.
So we designed the Eclipse Sun Shield, and what our device does is it goes on the roofs of different structures, whether they be residential or commercial. The Eclipse Sun Shield utilizes the James Webb Space Telescope Sun Shield technology in order to keep houses cool during the summer. This mitigates our societal need for air conditioners.
If you come to this wall now, you'll see a couple of slides talking more about the problem we face in the world with global warming and the depletion of the ozone layer. We believe that the Eclipse Sun Shield will serve to mitigate this problem by decreasing the need for air conditioners, which release CFCs and harm the atmosphere.
Yeah, so air conditioners are widely used in the U.S. As you can see from some of these graphics that we have here, their usage is increasing, especially in the southeastern United States, southwest, where the temperatures are extremely hot. And one of the largest issues with air conditioners are that they release CFCs, chlorofluorocarbons, into the atmosphere. And CFCs destroy the ozone layer at a very fast rate. Something around 1 molecule of chlorofluorocarbon can destroy up to 10,000 molecules of ozone. At the same time, the electricity that's needed the generation of that electricity releases greenhouse gases into the atmosphere, which promotes climate change and global warming. If you look at some of the graphs that we have, you'll see that the ozone layer is depleting at a rapid rate over the Antarctic, and there's actually a large hole in the ozone that's growing right now over the Antarctic continent. And so we believe that if we can limit the CFC release and we can limit the greenhouse gas emissions, we'll be able to significantly halt or better the climate change issue.
Another
Just to
major
continue,
factor.
another huge issue with air conditioning is that the electricity cost is somewhere around $11 million every year spent in the U.S. And this carbon dioxide that's emitted from generating that electricity is, as I mentioned before, contributing to the greenhouse effect. At the same time, air conditioning units are not a universal solution to hot temperatures. Many areas that are low income or don't have the infrastructure for electricity just cannot afford air conditioning. So we believe the Sunshield can offer a different solution to this problem.
As for the justification as why we need the Eclipse Sunshield, we need it because we further NASA's spin-off program by using the James Webb Space Telescope technology. In addition, the problem is relevant until we make a radical change to the way in which we cool our homes. And lastly, the solution can improve the lives of humans as well as preserve the Earth's environment. So now we'd like to invite you up the stairs where we will begin our design process with Alex and Isaac.
So now if you follow me up the stairs, we'll begin discussing our engineering process. The first step, obviously, of any process is to identify the problem. And the problem that you guys gave us from NASA was to take a piece of technology from the James Webb Space Telescope and put it to everyday life to try and improve the world. Some factors we took to consideration while we were trying to do this project was, of course, we wanted to make it so it fits all different types of people living in all various types of environments. It has to be relevant to everyday life, and the biggest and obviously most important was that it's eco-friendly. It helps the environment, which is the whole point, after all, of the Sunshield. As we were going over this project, we came to some reflections. Just real quickly, we wanted to choose a spin-off from the James Webb Telescope and focus to apply the Sunshield to real life. Continue. The step 2 was to identify the criteria and constraints of this project. Again, the biggest criteria we faced was that it has to be eco-friendly. It has to save the environment. That's, again, the entire point of the Sunshield was that it reduces the need for air conditioners, which release CFCs and harm the environment. Also, another big criteria was for it to be accessible to all the public and private consumers, meaning it has to be cheap, affordable for everyday modern people. Some constraints that we were faced with while doing this project were, again, cannot harm the environment. It cannot rely on electricity because electricity is not a resource that countries all over the world have. So we want to make it accessible to everyone. It has to be easy to install and it has to be safe for consumers.
So now I'd like to invite you to come up into the portal. So we're going to go through here. Quick update, Alex is back. We're going to invite you into the portal, so if you just walk through the portal, we transport to our gravity balcony. Welcome. So when you enter the gravity balcony, what you're going to see is the next step of the process, which was to brainstorm different ideas. So when we were brainstorming, we were thinking, what different ideas could we use? We thought we can make a picnic helper, a mobile phone case, an event canopy storage, and even a summer sportswear line. But then another idea that we had, which we eventually decided on, was the Eclipse Sunshield house cooling. So if we continue on to step 4, after we brainstormed all our different ideas, we actually have to select a design. And so to begin this process, what we did is we used the design matrix. What a design matrix allows you to do is that it allows you to rank each different brainstormed idea on all the different criteria and constraints that we set upon earlier numerically. This way, when you add up all the values, you can know which idea is the best one theoretically. However, we can't always rely on this, so if you continue around the corner, what you'll see is that we ended up weighing everything on a pros and cons table. And so we took our 2 highest ranked values from the decision matrix, which was the mobile vehicle cooling and the Eclipse Sunshield, and what we did is we weighed them out of pros and cons. And so in this table you can see the different factors that we were weighing when deciding the main topic. Eventually, when we laid these all out, after many discussions, long discussions, we decided that the winner of this, the big winner, the option that we were going to pursue, was the Eclipse Sunshield house cooling. So to sum up, what the Eclipse Sunshield does is that it protects our Earth by eliminating the CFC leaking air conditioners because it's installed on the roofs of houses, which will help them stay cool during the summer. It uses less electricity and thereby will limit the CO2 pollution. And it is able to help people of all different economic backgrounds, and it is adaptable to many different types of structures. So if you continue around the bend to get, again, we'll show you the basic fundamentals behind our idea. And so if you imagine that this is the vertex of the roof, what we have is we have solar panels covering almost rollers that hold the sunshield layers on them, and these rollers will extend out over the roof. And so they're held up by the solar panels. And the next picture depicts how this would actually look on a real house. So if you see, there's like a motor at the very bottom which would pull it down and allow it to go back up, and then you see the giant sunshield layers that are being pulled down and brought back up to protect the house from the sun while limiting the amount of CFCs. So now we'd like you to click the press to open the airlock button. Once you do so, you'll be back inside where you can enter the airlock. And because like all airlocks, there's multiple layers, so click the next button and then enter into the real inside area. And in this area, Alex and Isaac are going to kick it off.
So now, once everyone's inside this room, we'll begin discussing what we did further into this project with the next steps. So the procedure we took while building our prototype was to simply we gathered groups and reviewed again the criteria constraints that we discussed earlier in this project. We made sure that everything we were designing fit within the constraints and the criteria so that we would have the perfect project. While we were doing this, of course, we did our research. We learned how the sunshield worked, what materials it was made out of, and how it was able to reflect light and heat from the sun out of any object it was covering. Now, if you want to follow me into this alcove over here, we can continue the procedure. So again, we expanded our ideas and expanded our prototypes with what Jake was discussing earlier about the rollers on the roof. And these rollers are powered by solar panels. So again, it requires no electricity, and it allows the panel to be, or rather the sun shield to be rolled up during colder months of the year so that heat from the sun can get into the house, and you wouldn't be trapped with a cold house all year long. And then if you come further into this alcove, we continue the procedure and with more sketches illustrating exactly how our idea would unfold onto a real house. The sketch at the far end of this alcove demonstrates exactly what Jake was explaining earlier with the rollers, the panels, and the sun shield itself. So once we had all this research up, we quickly did the model, making sure everything, again, the constraints and criteria were hit, and we were on our way to the next step. So we'll wrap up this room now and enter into the James Webb Space Telescope display room up these stairs.
Hey guys, it's Isabel. I'm going to take you through the James Webb Space Telescope room. In this room, it gives a brief outline of a few of the many instruments on the James Webb Space Telescope. And there's so many instruments on this telescope that need to be kept cool. And one way that the NASA scientists thought of to keep the telescope cool was obviously to develop the sun shields. And if you come over these slides towards where I am, it gives a description of how the sun shield works. And basically how the sun shield works is that it directs the heat the telescope would be coming in from the sun out back into space in order to eliminate the heat excess that's coming onto the telescope to make sure that the pictures from outer space are coming in crystal clear.
Awesome, thank you, Isabel. So what we're now going to do is, I just want to make sure everyone's able to see the model of the telescope, which is in the middle room, and this is an accurate model of the telescope, so that we thought that it would be really cool to put the telescope in the room so that it would really show how the different features interact in a 3D sense. So when we are finished viewing the model in the rest of the room, I invite everyone to follow me up into the floater, which is the blue elevator-looking structure where I'm standing.
And it seems that Alex Lee lost his internet connection, so I think we'll be continuing the tour without him at this point.
So when you come into the floater, please just enter the box and then click on the sign that says click here. And then you'll be floated up using the warp feature and you'll be brought to the model room. Okay, so once we're on the model room, we're going to begin with the first model, Model A. And what Model A is it's essentially what the house would look like with the sun shield on it. So it gives you a pretty accurate representation of what the sun shield would do visually and how it would interact with the house itself. So as you can see here, we have the different sun shield layers on top of the house, and the motors is represented by this black box with the rollers up on top at the vertex of the roof. And you can see also the solar panels at the very top. I'd like to note that all these models were made using Google SketchUp and scaled using the software Accutrons. After we finish viewing Model A, I would love if you would all follow me to Model F over here. Also, please note that all the models from this point forward are utilizing the examine feature of InWorld. This means that you can click on them, you can left click on them, and you'll be able to twist and turn them to your liking so that you can better understand how the technology works. So Model F depicts the sun shield without the roof. So this is the technology itself. This is the Eclipse sun shield. And on the Eclipse sun shield, you see the blue on the top of it represents the solar panel layers, with the solar panel layers, which will protect the rollers from it'll protect them from the rain and the snow, the elements. But what the solar panels also do is that they also power the motor at the bottom, which is represented by that black box. And what the motor does is it pulls down the sun shields so that you can pull them down at they're flexible so that if you need, in the winter, if you need to have them up, you can keep them up, and in the summer when you want to have them down, you have them down. And so that's basically the point of the solar panels. They have a dual purpose. So after we finish viewing Model F, we can go into the next quadrant, which has Model E, C, and D. So Model E is really showing the hub of the telescope, of the Eclipse sun shield, and As you can see here, while utilizing the examine feature, it has the different rollers, which are suspended by a pole, and then they're able to roll with the Eclipse Sun Shield on it, and then above it you can see the different solar panels, which were protected from the elements. After Model E, we go to Model D.1 and D.2, as they're called. And the Model D, the different Model Ds, what they essentially do is they show how the technology would be retracted in the winter, in the summer, that is, how they'd be pulled down to cover the roof. And so essentially how it works is in Model D.1 over here, you can see that this is a motor, and as the motor spins and it turns the worm, which then rotates the gear, which then winds up the different tension cables, which pulls the sun shield down. And what really this does is that it allows it to ensure that each side is being pulled at the exact same amount, and each tension cable is being pulled the exact same amount, so that the telescope, so that the Eclipse Sun Shield isn't getting caught up, that it's able to remain parallel, etc. And the last model about the Eclipse Sun Shield that we'd like to show you is Model C. And what Model C is it's the Eclipse Sun Shield itself, the different layers and how they're suspended about the rollers without the hub, without the main cap.
So when you guys are finished looking at these models, you can follow me into the final reflections room. In this room, we made all glass, black panels to really emphasize the deep reflection we went through when asking ourselves these important questions. So the first question we asked ourselves was, how did the work we did during this project relate and compare to the work that real engineers do when they're trying to design actual projects? So what we decided upon was that by using things like the design matrix and the engineering process, we were doing actual things that real engineers do when they're faced with problems. The design matrix helped us go from 6 okay ideas to one amazing idea, which was the Eclipse Sun Shield. The second question we asked ourselves was, what difficulties did we have to overcome when working on this project? And I think, speaking for everyone, I think the biggest problem, one of the biggest problems, was that this program has no undo button. And this became a problem because when we were first starting out, we all tried to put in our own ideas. We all had a vision for this project that would compete with other ideas, and so what we do is delete others' works and put it on our own. And without an undo button, we couldn't take that back. We couldn't fix a mistake. So we really had to talk it out and think of the best ideas over group chats without being impulsive and deleting things rapidly. And then a quick second difficulty we had to overcome was feeling really overwhelmed when we first received this task, because it's a fairly large project with a lot of moving parts. But over time, we were able to take a step back, take a deep breath, and we broke down into manageable parts. We all took a share, and we were able to get it done. Some final remarks is just that the things we learned from this project are invaluable, and we really are appreciative of the opportunity to do this project and to go down to Maryland and present it further. It's really a great opportunity, and we're very, very grateful.
So after we exit the final reflections room, I'd like to ask everyone if they would follow me back down the center aisle of the model gallery and towards the exit, which is that red quarter the green quarter from which we came. So if you walk through the portal, through the exit corridor, you'll see the bump area, the bump panel, which essentially teleports you back down to the home.
Okay, so finally, to wrap up our presentation, we just want to talk a little bit about our marketing strategy for the SunShield. So first, we had the high schoolers listen to Dr. Joseph Holmes' InWorld lecture that talked about marketing. And for the target audience of our project, first, we're marketing to the judges because we want them to see that it's a feasible idea. But additionally, we want to market it to all home and business owners across the world who want to make a positive change on the environment. So there are a couple of risks associated with this, but they are very minor. So first, one worry was that the SunShield could be too expensive to produce, but all the materials are commercially available, so that shouldn't be too much of an issue. Also, the Eclipse SunShield could change the structure's facade because it is visible from the outside, so we want to make sure that it'll be as unobtrusive as possible, but some customers could see this as a potential issue. There are some contingencies as well, so the project appeals to those that are environmentally conscious, and as we'll go into more detail later on, the SunShield will be eligible for grants because of the environmental impact, which will offset manufacturing and retail costs. And additionally, it is very easy to be installed worldwide on millions of homes and businesses.
So there's a really large market opportunity for the Eclipse SunShield. After doing some basic research, we discovered that 90% of America's housing units use air conditioning. Thus, we can turn up to 90% of America's housing units into greener homes. Essentially, there is a huge need and potential customer base for the Eclipse SunShield in the Americas, let alone the world.
Okay, so in terms of competition, our competitors would be the air conditioning and fan manufacturers. However, we really want to make sure that we push that ours has a positive impact on the environment, which neither of those companies can claim. So they don't have an internally non-obstructive way to cool a home. Their solutions are not environmentally positive, and so therefore the Eclipse SunShield would be the best solution. And as we talked about earlier, there are grants that the SunShield would be eligible for because of its environmental impact and the use of solar panels. So first, the U.S. government subsidizes any home improvements that meet the IECC standards by 10%, and the solar technology on the SunShield makes it eligible for many solar grants. And this actually would allow you to save money because you could use solar panels to pump energy back into the grid, which would allow you to make a little bit of money to help offset any costs. And then additionally, there are also federal tax incentive assistance programs to help pay for the technology, such as the SunShield, which should help to offset most of the most expensive tech costs.
Well, when we were deciding on how we think would be the best way to advertise the Eclipse SunShield, we decided that we would have to take kind of two different ways. And so the first way would be to really focus strongly on the issues of our competitors. A, being the environment, because the air conditioners, which is the main competitor, would be releasing dangerous CFCs into our atmosphere. And the CO2 that is being created from the power plants producing the energy for the air conditioners is also destroying the environment. The other main the other main issue of our competitors that we'll be focusing on would be the cost, because the air conditioning accounts for approximately 16% of the average household's electricity bill. But then the other facet of our proposed advertising approach would be trying to really boost and explain explain the benefits of the Eclipse SunShield. A, the Eclipse SunShield does not require energy from power plants, and B, it's a one-time payment, and it will be very much subsidized by grants. So lastly, we're going to ask that you continue back throughout towards the main lobby and make a sharp left into the Communication Central. Communication Central is essentially just depicting how we worked together on this project and the experience that we had. And clearly it's pretty memorable, and we had a lot of fun doing so. And so as you can see from the picture on these walls, this project has been a long collaborative effort. We use many different mediums to communicate, whether they be Skype, email, or text. We bonded as a group. I barely knew my group mates at the beginning of this project. Now I feel like we're all one big NASA family. We also spoke with and helped different members from other InWorld groups, which really shows the whole collaborativeness of this process and this competition.
So that'll conclude the tour. We want to thank you so much for coming along with us, and if you had any questions about our design, just feel free to ask them right now.
Team 7, we want to thank you, Team 7, again for this wonderful introduction and tour. One question I would just like for anyone to respond, or all of you to respond. If a group was debating whether they wanted to enter the InWorld OPSPARC challenge, what might you say to encourage them to join the challenge?
I would say that this is a once-in-a-lifetime opportunity because you get to interact with NASA scientists, you get to really bond as a whole team, and you get to make a product that you're really proud of. The other main thing is that the real-world InWorld software is a really amazing technology, and to see your ideas come to life in a 3D environment, it's an experience that you'll always wish you had.
Yeah, I agree with Jake, and just to add on that you get to learn how to go through the research process and how to develop this creation that you work together as a team, and it's really just an awesome experience. And like Jake said, it's once in a lifetime.
And just to add on to that, as one of the mentors, I can say that in high school there were a lot of different projects and competitions I was a part of, but none of them were close to being this much on the national scale, with it being sponsored by NASA. So like Jake said, it really is a great opportunity to participate in a project that could have future career implications, something that you could put on your resume, and something that you could really learn a lot from.
And just one final note, this project, like I mentioned earlier, it may seem overwhelming at first with all the tasks you have to complete, but in the end, when you finally, finish your design, when you finally finish the InWorld museum, you win or lose, you feel some sort of gratification, being able to complete this amazing project, working with great people to do something that, so few kids get the opportunity to do.
Well, the NIA team and the NASA team, thank you all for your hard work and for your diligence, and we look forward to seeing you later this month at NASA Goddard Space Flight Center, where you'll be reporting out live to the James Webb Space Telescope researchers. Thank you guys. Thank you, Tori. Thank you, Dave, our Universe Master. And if you want to wave goodbye, we can wrap it up for tonight.
Thanks for coming and visiting our tour. Bye-bye. Lastly, before we go, I'd recommend that everyone start doing the Macarena.